Welcome to solving general triangles. Before now, we have gone through solving right angle triangles. A right angle triangle, we did say then that is a triangle that has one of its angles to be 90 degrees. And we did state there that there are limited tools that can be used to solve right angle triangles. And those tools were the Pythagoras theorem, the trigonometrical ratios, just those two. Pythagoras theorem and the trigonometrical ratios. However, what about if a triangle is not a right angle triangle? That is where we don't have any of the angle to be 90 degrees. How do we go about solving for the lengths of the sides of the triangle, or even the angles of the triangle? Two tools are available: the sine rule and the cosine rule. In the next two video clips, we are going to consider these two. This video clip will consider sine rule, and the second one will consider cosine rule. Application of these rules, practical applications of this rule, will be seen in the topic called bearings. First, we look at sine rule. On our screen, we have here a triangle ABC labeled with uppercase A, uppercase B, and uppercase C. And then the lengths of the sides are labeled with lower cases, lowercase a facing the angle A, lowercase b facing angle B, and then lowercase c facing angle C. We'll go straight. This kind of a triangle is referred to as an acute angle triangle because you can see all angles there are less than 90 degrees. The rule does not cover only acute angle triangles. It also covers what? Obtuse angle triangle. That is, triangles that are not where one of the angles may even be greater than 90 degrees. Yes, as you can see on the screen here. On the screen here, we have a second triangle to our right. And you can see here that the angle A. Let me change the color of my marker to black. You can see here that the angle A is obviously greater than 90. This kind of an angle is often referred to as an obtuse angle triangle because it is greater than 90 degrees. But in the first triangle to our left, all angles there, A, B, and C, are obviously less than 90. So we refer to such a triangle as what? Acute angle triangle. The sine rule is simply stating that the ratio of a side to the sine of the opposite angle, let's say I take the side labeled A, the length of that side, divided by the sine of the angle facing that side A, in this case, angle capital A, that it will be the same thing if I take any other side, say B, and divide by the sine of the angle facing that side also, in this case, angle B, or even if I take side C, that's lowercase c please, the length of side C, and divide by what? The sine of the angle C, which is facing the length of the side C. So the rule simply says that the ratio of A to sine A, or B to sine B, and C to sine C, either for an acute angle triangle or for an obtuse angle triangle, is a constant. That's the summary there. That A over sine A is equal to B over sine B, which is equal to C over sine C. We'll quickly look at an application of this. On the screen here, we have a triangle ABC. We are told that in the figure above, we should find the length of the side labeled X. If I am to go about solving this, I look at this triangle carefully, and I notice that there is no angle that is 90 degrees. I say, oh no, I cannot use Pythagoras theorem. Neither can I use SOHCAHTOA. That's the trigonometrical ratios. Then I have to look at sine rule or even cosine rule. Right now, let's consider sine rule. For sine rule, if I'm looking for X, I obviously have to establish the ratio X all over the angle facing the sine of the angle facing that side called x, which is 80 in this case, then equal to, then I must take another ratio here. In this case, I must know both the numerator and the denominator. Looking at the triangle, we have been given the side labeled how should I call it, the angle 60, and the side facing that 60 is 7. So I think we are covered there. So I can say, okay, that means that the length 7 divided by the sine of 60. That's my sine rule. If you like, you would have also start taking this way. Let me change the color of my marker. Well, you would have said this is would have called this side B because it's facing angle B. You could have also called this side A since it's facing angle A, and call this side C. Then you may have established just, okay, since I'm looking for side B, I have to write that ratio out there, B all over sine of angle B, which is known, but we are looking for this. Then the right hand side, we must know both up and down, and we look at A. So we know the length of side A, and then sine of angle of A is also known. And that's exactly what we have done there. So let's continue. I change the color of my marker back to white. I come here and say, okay, I have x all over sine 80 equals to what? This is 7 all over sine 60. Find the values of sine 80 and sine 60. Yeah, on the screen here, we can see that what? That sine 80 is 0.9848 and sine 60 is 0.8660. Cross multiplying there, we have 0.866 times x equal to 7 times that. And then playing around here, we have x as 7.96. You can see how beautiful the sine rule has saved us, where Pythagoras theorem and the SOHCAHTOA phenomenon that we've been using failed us. Let's advance and look at another example. Solve for the labeled sides in triangle ABC. We are given two sides to solve for here, ABC. I say, okay, sorry, A and B. C is given. The moment I find that C is given, that encourages me that I know both angle C and side C. So I'm going to establish C all divided by what? Sine C on my right hand side. Since the length of side C and the angle C, which is 29 in this case, is known. Then let me go out to look for A first. Do I know angle A? Yes. Now if I want to find B first, I would have said B all divided by sine of B. Unfortunately, I do not know B. But even at that, I would have just said, oh, this is a triangle. The sum of all the angles in a triangle is what? 180 degrees. So I could have just added what? I'll say my B is what? Is 180 less the other two angles given to us, 100 and then 29. And that would have given me 129 from 180. That is 51 degrees. I would have used that to find B. However, for me, I want to find A first. No special reason for that. So I wipe this. You can go as well as, if you want to, and look for B in your own case. In my own case, I've decided to look for A first. My eraser is not working. Expected. Okay. I'm looking for side A. I'll divide that by the sine of the angle of A. On the right hand side, I know length C and I know angle C. So I'm on. So I have only one unknown there. I say, okay, A divided by sine of 100. That will give me what? 3.2, which is my C, divided by the sine of 29. Now, if you are using a four-figure table, you may not be able to get sine 100. So you can just quickly do what? 100 is in the second quadrant. So you can say, instead of 100 degrees, we can obtain what? We can go for 180 minus 100. and that will give us 80 degrees. 80 degrees, that means I'll be looking for sine 80. They are equivalent. Sine 80 and sine 100 are equal. So I'll say this is A divided by sine of 80 equal to 3.2 divided by sine of 29. But if you're using your calculator, you can go ahead and just solve with sine 100. There is no problem. So there we have 3.2 divided by sine of 29 equals to what? Equal to A all over sine of 100. We find the value of sine 100. Sine 100, which is the same thing as sine 80, will give us 0.9848. And then here we have 3.2 divided by sine 29, which is 0.4848. Of course, we cross multiply there to solve for A, and our A comes out as 6.5. So that's it for A. Next, I go straight to look for the other labeled side, B. We can hurry up this time around to find our B. Just quickly establish that B all divided by sine of B. I'll still make use of my C. C divided by sine of C. My B, not known. Angle B, we solved the other time as 51. Remember, we obtained it as 180 minus 100 plus 29. Sum of angles in a triangle is 180. And then this is 3.2 divided by sine of 29. Then you progress there. As you can see here, we have obtained here sine 51 is 0.771. We cross multiply again, and we have this line. Solving for B, we have that. So both labeled sides have been discovered. A is 6.5, B is 5.13. We'll take one more example to emphasize more on what? On solving general triangles using the sine rule. Find the value of the length of the side labeled X in triangle PQR. Oh, the triangle is actually labeled PQR. Let's quickly label that triangle. Let's call this P. Let's call this Q. And let's call this R. Okay, in this case, it's going to be our R, which will be lowercase p. R has decided to disappear. Let's bring it back. And this is Q. I am asked to find the side labeled X there. And that means R. If I'm going to do that, then I have to use the ratio R divided by sine of R. But there is a problem. If I'm looking for R, I must know this angle. Because the right hand side, of course, is already known. We can use Q, which is known, all over what? Sine of Q. But looking at the triangle carefully, we are only given one angle. There is no way we can obtain R straight away. So we may suspend this and find another way to find R. Let's look at P. The side P has been given. We can use this P against angle P to find angle P. Once we know angle P, oh, wonderful. We simply add the two up, subtract from 180, and that will give us R. And then we can come back there to solve for what? Our R. So we are going to do what? Ask this expression to please hold on, that we are coming back, because if you're going to work with you now, we are seriously limited. We know Q, we know this Q, but we do not know capital R, so we cannot solve for R. So just hold on, let's go and look for R and come back. That's capital R. I say, okay, we use P all divided by sine of angle P, that's the uppercase P, is equal to what? Q, which is known, all over the sine of angle Q. My P is 10 centimeters. Angle P is not known, so we are going out to look for that. Q is given as 12 centimeters. And angle R is given as 70, angle Q. So that will be sine of 70 degrees. Now we manipulate this. Manipulating this there, You can see you cross multiply. Look at them there. That's 10 over sine P. 12 all over sine Q. Sine Q, which is sine 70, 0.9. That's it there. 93797 rather. If we cross multiply here, we have 12 sine P equal to 9.37, 9.397. And then manipulating here, we have sine P equal to that. The sine inverse of P gives us our P as 51.4. So now we know the angle P. We can go out to get what? Get the angle R. Do not forget that this is our P, that's our Q, and that's our R. So let's go on. That's our P, Q, and R. So now we are looking for X. Remember, X is the same thing as lowercase r. And that's it there. Look at it. Now that we know P, we can easily obtain a value for Q, for angle R. And that's what is being obtained here. 180 minus 70 plus 51.4, that is angle P and angle Q. Subtract that from 180, that gives us the angle R. Now we go back to our first expression. R all over sine R is this, and then this is our Q all over sine Q. So that's the expression we are applying. And then substituting those values, we have the expression here. Cross multiplying, we have 0.9397 R is equal to 10.23. Rearranging these, we obtain our R as 10.7. Remember that R is the same thing as X. So we have obtained the value of X in triangle PQR. I'm sure there's nothing so special about all this. Sine rule, a very wonderful rule. Even at this, sine rule may not be able to still solve all problems. As a result, we have a very close cousin to sine rule, and that's the cosine rule. So in the next video clip, we'll consider the cosine rule. Thank you.